Don't forget to check out our resource page at mimakiusa.com. Here you can find webinars, application guides, tips, tricks, techniques, and more with the applications team, and many more informational videos to help you get the most out of your Mimaki product. Want to see upcoming Mimaki events and webinars? Well, mimakiusa.com has you covered. Make your way over to the events page available on the About tab. Mimaki USA also offers a support page that includes driver and software updates, a color profile center, frequently asked questions, and more.
Welcome to another episode of Mimaki Live. Thank you for joining us today. We appreciate everybody that is in the YouTube channel with us right now. Thanks for joining us on this live stream. We are very excited about today's episode. Couple quick things before we get started. For those of you who have not participated, this is a live presentation of some of the things that Mimaki offers into the marketplace. If you have any questions or if you have any ideas that you want to share with us, you can feel free to put those in the chat window. We are a focused company. We manufacture printing and cutting devices for a couple different markets, sign and graphics, industrial products, textile and apparel, and a subset of our industrial product category is what we're going to be talking about today. I'm Michael Maxwell. I am the Senior Manager for our Corporate Strategic Development here at Mimaki USA, and I am joined by...
I'm Lewis Jones. I'm an application specialist here in Atlanta. Like Michael said, we are going to be focusing on a different segment than our previous episodes. We're going to be focusing on 3D, which should be a very exciting episode. But we're going to do things a little different in this episode, only because we are not the best people to talk to about this subject. We have an amazing 3D team here who make wonderful graphics, make great applications, know the software much better than we do. So we're actually going to turn over towards them for the majority of this live. We're going to have them on later. We have people from our team, Josh Hope, Fred Kaplan, Jaime Martinez, and a little later on in the program, we're going to have one of our customers from Objects Unlimited, Steve Corey, on for a video to show you a little bit about something that they're working on. And then we're going to have an interview with Dave Cowley from the Art Center in California. He's going to talk to us a little bit more about 3D. Dave Cowley and all of our Mimaki employees are going to be on at the very end for our Q&A portion. Yep. So throw all of your questions about 3D in the chat. If you see anything cool that you'd like to learn a little bit more about, post it in the chat. We will talk about it at the end. Hopefully this will give you a little bit of insight on how you can use our printers to up your 3D game.
Yeah, and in 3D printing in general is such a broad subject. We're not going to be able to cover everything, but we will cover some specifics as it relates to where Mimaki represents the 3D space. So we have representation for our little 3D-FF222, which is a filament-based machine. We have our 3D UJ553, which is a photopolymer resin machine, full color, really amazing piece of equipment. And then we've got our 3D GD 1800, which is relatively new to our portfolio, which is a gel resin based machine. All kinds of different things that you can do with it. It's such a large conversation that we can have today. We hope you have a lot of questions. We specifically wanted to make sure that you had an opportunity to see some of the information that we want to share, and have that opportunity, as you know, as you mentioned, to talk to our resident experts at the end of this, and we'll stick on for that. And if you haven't checked out the website before now, definitely check it out. Check out our YouTube channel, follow, like, subscribe, all that good stuff. So yeah, Lewis, 3D. I mean, you've had an opportunity to work with 3D a little bit here and there.
I'm familiar with it in the same sense that a lot of our customers, a lot of people watching might be familiar with it. There are our 3D FF machine. That's the small one. That's the most accessible for people. That's the kind of 3D printing most people are familiar with. Very small figures. You can buy that for your home. You can find a file online, send it to print, and it will make a structure very quickly of this filament material, using this filament material. And the second it hardens, it will make a 3D shape, and it has different structures to hold it up. You take away those structures, and you're left with the finished product. That is the kind of 3D printing that most people are familiar with. I think we showed that on one of our first
episode.
Yeah, on our first episode,
Very
and we were giving one of those ways of the promotion. Yeah,
we did.
That,
we did.
Even though that's what most people are familiar with, there's a step above that that other people might be a little more familiar with,
Right.
getting more expensive 3D machine, but it's the same process. It's the same. You can't do a lot more than what you could on the smaller machine. It's just a little bigger, and that's usually where people stop. We have a different set of machines that can do a lot more. Yes, we have figures from our 3D UJ 553. That machine can print out objects with color, with texture. We have some of the examples right here. Yeah, those, because you can choose the texture on the computer and choose the color on the computer, it comes out basically finished. There is a finishing process, but it comes out like this. And you can get a lot of cool effects with that. You can also get, if you print it correctly, you can get like glass. You can print out a glass bottle with the glossy texture of like an actual glass bottle. You can get really cool effects with this. And there's a lot of different applications that you can have with a printer like this. Obviously, some businesses will use it to make figures, tabletop miniatures, practical things like that. But businesses also use it for things like this. This is an example of the car seat from from the textile show that we did.
The textile episode, and then we also did the wrap episode where we showed off some of the capabilities of our textile printers. And this is a mock-up of a seat, very similar to what we did in a two-dimensional plane.
Yeah, exactly. So that company who would be making seats like this, they would print something like this out to get a 3D representation of what it would look like before they invest the money in actually manufacturing a bunch of these for production, like just showing it off to a board, showing it off to their investors to let them know what they're getting into. Of course, you get the same thing with architecture firms, with building construction, medical firms printing out some of the objects you can print out look exactly like a diagram of an exposed bone, muscle on it. You can get it very detailed. Medical professionals will use that to show off exactly what kind of work they're doing, and show off to other investors what kind of things they're doing with their jobs to help get them money. It's very versatile.
It's so broad. And I should mention that this piece here, you probably saw Lewis handling it a little gingerly. It's actually two separate pieces that are printed individually and then compiled together. So you can actually build these objects where they're to be assembled after the fact. So there's a lot of really neat things you can do. So you don't have to be limited to just the size of the print area, if you will. You can combine parts together And you can combine parts from multiple machines as well. So you can combine parts from our
Yes.
3DFF and our 3DUJ and our 3DGD, and you can combine
Yes.
those and also marry those to our 2D technologies, which is, it's just, there's a lot of wow factor there.
Yes, a little bit later, we're going to show an example from our 3DGD, which is our large 3D printer that can print out very large, that is made to print very large objects. That one, we printed out a figure on that, and you cannot actually print with color on that one, but that is something that you would use our wrapping technology. We would use our 2D printers. We would use our solvent printers to print out a graphic to be applied to that, to be laminated and then applied to that. We're going to show you a video of that process. You can get wild effects with that one. That's you can populate an entire showroom with just objects from that machine.
So we're obviously very excited about it, and we don't even work specifically in that particular space. So
this is the most shared thing that I post online. The stuff that they produce is the stuff that I pull up whenever somebody asks, "What cool stuff are you doing at Mimaki?"
So let's jump into the experts that actually know a lot more than we do about this, and we're going to jump to a couple of places here. So follow along with us. Follow, subscribe, like, put your chat window questions in there. We're going to answer as many as we can. The more questions we have, the longer we'll be on, so stick with us. And then, as we mentioned, we're going to have David Cawley from Art Center to come on. He is going to talk about 3D in general, not specifically just to Mimaki, but in his world, the education piece, and what his students are doing in his environment there, and also once they leave. So stick with us. Got a great show. So we're going to jump into a video here with our resident expert, Josh Hope, and we'll get started there.
This is the Mimaki 3DUJ553. This is our full color 3D printer. It's a large format printer capable of photorealistic output. This machine uses photopolymer resins. They're pre-pigmented. They start life as a liquid. They jet through a series of industrial inkjet heads, and then we UV cure them to a solid. The machine also jets a water-soluble support material. This material goes through the industrial inkjet heads. It's UV cured to a waxy type consistency, and then water is used after the print in order to dissolve it, so you're left with the final printed piece. The bed size on this machine is 20 inches by 20 inches by 12 inches. So you're able to do very large pieces, or you can do a series of smaller pieces to increase your efficiency. This machine uses a dual LED UV curing system. On the carriage itself, there's 2 LED lamps. So as the ink droplets are being placed, they're being cured to a solid using these 2 lamps. The 3DUJ553 also uses a flattening roller to ensure layer thickness. We have 4 different print modes on this machine. High speed at 42 microns, standard at 32 microns, and high quality at 22 microns. We also have a special mode for clear that's 19 microns. Inside the machine, there's a series of 5-liter ink tanks. The printer actually prints using the resins from those tanks. This way, you're able to change the external ink bottles while the machine is running. So the resins are supplied in 4.8-liter bottles for the support material, the clear and the white, and 1-liter bottles for the cyan, magenta, yellow, and black. The bottles are put into the system along with the ink chips, and then the ink is pumped from the external bottle into an internal ink tank. Another unique feature of this printer is the capping station. A series of silicone rubber gaskets seals around each head individually when the printer is not in use. This keeps the maintenance low, as it keeps any air, dust, or debris from getting into the print heads themselves. In addition, there's a silicone rubber wiper blade, which will squeegee off any excess ink from each individual head. These 2 features together help to ensure low maintenance times and high uptime for printing. So I'll open the cover up while it's printing so you can get a better view of what's going on. So as the print carriage is going back and forth, you'll see the UV LED lamps illuminating on the left and right hand side. The flattening roller is in between the left-hand lamp and the print carriage. The table itself is moving in and out, and at the same time, it's moving in the Z-axis up and down. This is what gives us the different layer thicknesses. The movement of the bed is controlled by a series of ball screw drives. These are highly accurate and make sure that every droplet on the machine is placed exactly where it needs to go.
This is what a final printed bed looks like. These models were laid out in our 3D Link software in order to get an optimal print layout based off the bed size and the model size. The majority of the cured support material can just be broken off the model and thrown away in the trash. The remainder of the model can be put into an ultrasonic bath using water, heat, vibration, and detergent to remove the remainder of the support material. Once that is done, you're left with your final finished model. This is a great example of industrial or consumer prototyping. So this is a project that was done by Hussein Al-Moussawi for Adobe Substance using their Adobe Substance Painter software. The software was used not only for the color portion, but also to get the texture for the fabrics and for the rubber part of the sole. This is a great example of what the Mimaki 3D UJ553 can do for the collectible market. So this could either be short-run production or it could be a prototype piece. This was actually done by the artist Carlos Ortega using ZBrush. This was sculpted and printed out in 3 pieces. So you've got each of those wings is a separate piece, so that we were able to print this laying down flat and to maximize the print area of the bed. So having a 20 inch by 20 inch by 12 inch print area allows us to do larger pieces, but in some times like this you may want to separate those pieces in order to optimize faster build time. This is an example of a print that could be used in the museum or the antiquities market. So this is a 3,300-year-old bust of Nefertiti that was scanned by the Egyptian Museum and Papyrus Collection. That data was locked away for many years, and then an artist named Cosmo Wenman was able to get that data released into the world and can be used now under a Creative Commons license. So this is something that you could use to reproduce art pieces that could then be shown in different locations, or allowing museum guests to be able to actually handle the models. The automotive market is another group that was very quick to adopt 3D printing technology. So this is another sculpt done with Substance Painter for the texturing. The artist was Dixon Castro, and this is just showing a possibility for a design for either a video game car or a real-life prototype. It's a great way to, again, take something that you normally see in 2D and get it into the 3D world, where you can hold it in your hand and look at it from all angles and really get the feel of what an object will look and feel like. In the video game market, printing game assets is also a possibility. This is a ZBrush sculpt done by the artist Kevin Brunt from the game Metal Slug. It's a great opportunity to take what's traditionally a 2D artist rendering and turn it into a physical 3D object.
Hi, I'm Steve Corey, President and founder of Objects Unlimited, coming to you from Toronto, Ontario. We do a number of different things here. Objects is a reseller of 3D printers and 3D scanners, and we also operate a service bureau where we produce parts on demand. One of our specialties has always been high detail organic shapes in full color. We've been working in the figurine market for a number of years, producing parts for people all over the world. But we're always looking for a better way to do things. I was really intrigued when I first heard about the Mimaki 3D printer. The sample parts were really incredible, almost too good to be true. After careful consideration, in January 2020, we decided to take the plunge and install the first Mimaki 3D printer in the Canadian market. I can tell you now in retrospect, this was an excellent decision. This Mimaki 3D printer has helped me expand my business and my product offering. We're able to print parts in a level of detail and with color accuracy that we just couldn't achieve with any of the other equipment that we have. We've run 2-hour jobs on this machine, and we've run 70-hour jobs on this machine with outstanding results. A couple things I really like about this machine aside from the obvious part quality. First of all, it's a closed loop machine. That means that almost 100% of the material we use goes into producing the part rather than into the waste tray. This saves a lot of money. Also been pretty impressed by the material cost. Parts are coming in much cheaper to produce than we originally anticipated. You know, one of the keys to being a value-added reseller is understanding and using the machines that you sell. We won't sell something that we don't understand and that we don't trust. I'm really pleased with our decision to buy this Mimaki 3D printer and add it to our product line. It's sometimes hard to believe all the marketing hype, but seeing is believing, and after several months and more than 150 successful 3D print beds, I'm definitely a believer.
Okay, and we're back. I hope that was, I know that seemed like a lot of information. I hope you got a lot of good inspiration from those videos. You saw Steve Corey and some of the stuff they were doing down in Cali. That was amazing. Thanks to Fred Kaplan for helping out getting that interview.
Absolutely.
Josh Hope and Jaime Martinez. Jaime was the one who helped me with the wrapping on that video of the ice cream sculpture that we did with our 3D GD. They're all going to be on at the end for questions and answers. So keep on populating that chat with all the questions you've had. Saw something cool, let us know. All of those videos, by the way, will be up online later. So just make sure to subscribe to our YouTube, follow us on all social medias to get all this information. If we do anything new that we haven't shown yet, that'll be posted on there as well.
Yeah, and like I mentioned earlier, I know this was just a small sampling of what we can do in those videos we just showed, but the 3D space is such a broad subject. So we've got one of the experts in the field, David Collion, with us. He is going to join us from Art Center out in California. And David, are you on with us?
Yes, good morning.
Good morning. Thanks for joining us. So we've got a lot of different things we can do with just the products that we have, but 3D is such a broad subject. And we know that you're on the forefront of teaching people how to conceptualize, implement, and execute different 3D technologies and workflows. So why don't you tell us a little bit about yourself and what you do?
Yeah, my name is David Corley. I'm the director of the model shops and 3D labs here at Art Center College of Design in Pasadena, California. We have multiple disciplines here. We have product design, transportation design, film, photography, fine art, and environmental design. We also have, extensive model shops and extensive 3D labs. So it's about bringing all the technologies together. We have a wide range of 3D printers. We have SLA, we have FDM, we have powder jet printing, combined with CNC, laser scanning, and other traditional shop practices. And what it is, it's really about the department's functioning as almost like a service bureau to students. It's a design college, so students are designing products, cars, different things, and then they're making physical models. And what we do, the shop's role is to, students are creating files and designs, and we're processing them very much like a service bureau. So the students need to really understand, what's available to them. And our job and my goal here at Art Center is to keep us really on the leading edge of technology. So 3D printing, it's a rapidly evolving technology. So we're always looking at different types of 3D printers, different ways of doing things. And I always say to students, there's, the toolbox right now is just getting bigger and bigger. There's just so many different options for you to do stuff. So that's where we are at Art Center.
Yeah, well, thanks for joining us. We certainly appreciate having an outside viewpoint.
Right.
As we talked in previous episodes, we know the world as it pertains to what we know, but having other guests on and other industry experts come in and speak with us is invaluable to our customers, because it also shows a different perspective of things that we may not have thought about on how to use. Right. So, yeah.
And I'm always looking for application ideas. So. How are some of your students utilizing 3D technology right now?
Right, and that's a good one. The way that students utilize the 3D technology, and again, this is across disciplines. Everybody is looking at 3D. It's a very exciting time for 3D printing. So everybody's kind of wanting to utilize it. An example would be like for transportation design. We primarily work in 5th scale. So we have 3-axis and 5-axis CNC will actually machine foam, and then for trim, for wheels, for different parts on those physical models, that's where 3D printing comes in. So we'll print, they'll make files for the wheels, for fenders, for lights, and different parts of the cars. So transportation is a big user of 3D printing. Product design, again, an area like product design, a lot of packaging and different things that are going to be involved in there, different prototypes. One of the things with the machines that we have, they're very much making prototypes. So these are, aesthetic models. There might be some functionality to it, but they're primarily making, prototypes and iterative models and designs. So they're using their designs, and what the 3D printing is allowing them to do is to, constantly iterate. Whereas if we go back and think of traditional shop, you would invest a lot of time making a model and then trying to change it and do things. With 3D printing, you can quickly, modify the CAD and be getting onto the next iteration pretty quick.
Yeah, and further to that, I mean, we hear a lot of acronyms: SLS, FDM, SLA. When it comes to these different projects and how your students use it, how important are the materials to the process?
I think that's a good question. It's very important. Again, becomes, if you think about a prototype or a really nice aesthetic model, the amount of finishing that you're going to need if you use a certain one of these technologies. For example, if you used FDM, you're going to have, some small layer lines, and you're going to have some sanding and finishing on there. If you're using an SLA, which is a resin printer, which uses the laser to harden the resin, has very high resolution. So again, you're not going to have the amount of finishing. You're going to get a more beautiful looking model, but you sacrifice some of the material strengths. So when we talk about materials, it's really about degrees of functionality that you want out of those models. If it's primarily aesthetics, then you want to be looking for a printer, that can output something that's going to require less finishing, maybe has some options with color and different things. But if you're looking for strength of material, then you're looking at some of the filament machines and different machines that are going to output parts that are really made from the real material, the material that matches, let's say, an injection molded part. So we could actually, put these models into a test environment, and, manufacturers can get an idea of how the real parts are going to perform, even from a 3D printer.
So from our world, our perspective, we've got gel, we've got filament, we've got inkjet, photopolymer, resin. How many materials are there available in the 3D space right now?
There's too many to name. I think, yeah, there's a lot. And again, the thing has always been, okay, let's look at real products. If we're looking to, do manufacturing with 3D printing, then we have to look at what those products are made from. If it's ABS plastic, which is a very common injection mold material. So the idea is, okay, if we're going to use a 3D printer to kind of mimic that, we're going to need those material properties from that printer to be very close to the injection molded part, so that we can actually, use that to actually manufacture as well as prototype. And I think that's one of the areas where materials play such a big role in the ability for 3D printers to actually get into manufacturing.
Yeah, and you mentioned manufacturing, and in a previous conversation we had, you mentioned, I think the acronym is DDM.
Right.
What 3D materials are used for those in real world manufacturing processes? Right.
For DDM, direct digital manufacturing, I mean, you're looking at FDM technology with filaments. Having said that, on the resin side, the improvements in SLA resins has been really accelerated over the last few years. I remember in the very beginning, the SLA resins were, they were notoriously unstable, a little, things didn't have the strength, or the machines weren't curing it the way it should be. Today, these materials are very close to real materials. So I think across the board, manufacturing is looking at this technology. I know HP with jet fusion, they have a powder technology where it's basically the powdered material, nylon, real materials that are making real products that are out there. So again, there's just a really wide range of applications and materials.
Awesome.
Right. I wanted to bring it back to designers. What role do you see design playing in 3D, or how important is design when it comes to like new people trying to get into the field, new people trying to understand 3D, but coming from a not 3D background, more design based, more graphic design based?
Right. Yeah. I mean, obviously there's a lot of software out there. If we think about the two things that have to happen to create a part with a 3D printer is, first you need to create a file. So you're looking at, some of the modeling software that's out there, some of the CAD packages that can output the files that the printers can read. So typically, there's a lot of CAD out there. And here at the college, we have, across those multiple disciplines, we have different preferred software, if you like, different CAD packages that perform well in different areas. Like SolidWorks would be a package for product designers. ZBrush would be more for film photography and more high resolution type prints and designs. Alias, Rhino, AutoCAD. So really getting familiar with the CAD systems that are out there and looking at what you're trying to create. There's definitely a CAD package that's suited to different disciplines. And the beauty of 3D printing is no matter what CAD package you're using, if you can output the files, the STL files or step files or vermal files. I know I'm using a lot of acronyms again here. It's a game of acronyms. But if you're outputting those files from any of those CAD packages, you have now the option to print on any machine. So it's so universal that you can send that file anywhere in the world, print on the latest and greatest metal machine, or bring it right back and like you talked about earlier, print on a little hobby machine on your table at home. So it really does transcend.
Yeah, I know that does seem like a lot of terms. Maybe some people are getting might be intimidated, but there is a universal transfer of skills that any base leveler should have with before getting into these CAD programs. ZBrush, it's was very easy for me to pick up with just a 2D illustration background. What skills should designers have when they're trying to adapt things to 3D? I know, of course, like lighting and we have our machine that works mostly in adding texture and color to objects.
Right.
Knowing like how shadows play with different textures is a skill that I would like to have when I'm setting up a file for like a printer that can generate textures.
Right. And again, here at Art Center, one of the things we do is we look across the broad range to really understand 3D and to get the best output from 3D printers. You really need to have some kind of hands-on skill. So even today, as much as you can jump into CAD and you can print things and you can, make really incredible things, you can make bad 3D prints. And I think that's a good point. You really need to understand some of the basic things that are going on there. And I think, if you've got traditional hand skills, and I think it's really an area where traditional model shop fits in with 3D printing, they go together really well. You understand, fit and function, you understand how things actually go together, because 3D I know you talked a little bit earlier about, you can make assemblies on these machines and assemble really big parts from small machines. If you understand, that when you're working in CAD, there's tolerances and things that you need to design into these models to make them work. So I think you really have to understand, some traditional skills. They do transfer into, being able to use CAD packages and design and understand what's going on in there so that you'll have a good outcome with a 3D print. So I think it's, a lot of things.
Yeah.
Right. Earlier in the show, we had brought up some videos with like two different methods of coloring 3D objects. We saw with the 3D UJ 553 system of printing out something already pre-colored and pre-texturized, and then we saw with the 3D GD wrapping something that couldn't come out colored. What are your thoughts on color with 3D objects?
Well, it's been a milestone really in 3D printing to really achieve true colors and really good colors. And I think now that arena's opened up with Mimaki and some other equipment that can really produce beautiful colored models. And it's a game changer, in my opinion. As an example, we had some samples made and full color models. We have a packaging track here, and I took some of the actual bottles and parts down into, they were designing and getting ready to make like perfume bottles and different things that they were making in packaging. And the way they were doing it, they were using 3D printing, but then they would have to create a silicon rubber mold, pour in the clear materials or the tinted clear materials to produce that. I showed them the parts and they couldn't believe it. They thought they were actually castings, not actually printed. So,
right.
you know, the difference now, I think, with color is we have real color. In the past, it's not been the way it is today. I think the technology has taken a quantum leap with color, and it's really important in a design school. You know, we're finishing a lot of the work that we do here is finishing, sanding, painting, and prepping of 3D printed parts or conventionally made parts. If you think about taking those parts now out of the machines with all the color and different things on them, it's a game changer.
Have you ever had problems getting some of that information across to the different students? I know when I'm sharing information with my friends who are familiar with 3D printing, I'll show them then something that we've printed on one of our machines. They will not believe that that something like that came out of a 3D printer. They thought that 3D had gotten to a certain point and then stopped learning, or they saw the stuff that they get at home for very cheap and then stopped figuring out what new stuff is out there. So has that been hard trying to get some of that information out there?
I think it's been hard a little bit because I think the explosion in 3D printing in recent times came from these small little hobby desktop printers. And everybody thought, wow, you know, a printer in every house was the motto that was going around. And people looked at the output from those machines and said, well, yeah, it's good, but this isn't going to revolutionize the world. And then, like you're talking about, we really have three different levels. We have the little hobby machines, and then we have some very good prosumer type machines that can output really good things. And then there's the big industrial side of it where we're printing real objects, or we're using these machines to make, you know, full color models that are true representations. So yeah, there's definitely three tiers. And I think some people do kind of stop at that first one and see it and go, well, you know, do I need this? But once you go further and you get to those next levels, then you really see the potential. And like you say, people are, their minds are blown. They're like, well, this is incredible. I don't believe that could be printed. So we've had some of that, even from students who are around 3D printing and even faculty. So yeah, it's got a great wow factor right now.
Well, we certainly are wowed by everything that you guys are doing out in the field. So we're speaking with David Cawley from Art Center. We're going to have you stay on for a Q&A, but before we do that, you know, we talked about a bunch of different techniques, a bunch of technology, software, design, acronyms, right? The sea of acronyms, like you mentioned. David, where do you see 3D going as it continues to evolve?
I think really the future is going to be amazing. I think as much as 3D as you know, accelerated and improved, and materials have improved, I think there's still a lot more that's going to come out of 3D. I look at a lot of different new technologies and ideas. I mean, just ideas that are coming out of where these technologies can be used. And I think it's very important here as a design school that we start to design for 3D printers in particular. It's going to change the way products are made. It's going to shorten design cycles, and it's going to allow us to do things, you know, free up designers to actually use 3D printers to create products that are lighter, stronger, and better than what we're making conventionally right now. So I think, you know, you think about 3D printed metals, you think about bioprinting. I know these are all different areas. We do tend to think of 3D printing as making models and prototypes, but it's reaching out into just all areas of manufacturing. I have quite a bit of background in the foundry industry, And right now there's machines that are printing with sand and binding sand and printing molds. And then we're pouring metal directly into, molds that would have been created completely different way. So it's the beginning of really the technology reaching into manufacturing in all industries.
We might need to have you on later to talk about that on another episode.
Yeah, absolutely.
Yeah.
Well,
The future, yeah.
So from our end, you can go to MimakiUSA.com to find out anything about our equipment. You can check out our YouTube, our Facebook, our Twitter, our Instagram. I'm probably missing a few in there, and you can see videos and all that. But for designers or people that are interested in this that aren't a current customer or in a space where they're going to be a customer right away, but want to learn about this, where should they go to get more education from you and Art Center?
In terms of learning about 3D printing, the internet. I mean, you think about classes. I mean, we run classes for 3D printing, but I think the way 3D printing is now, it's getting woven into schools, into junior schools, high schools. Students that are coming to college have already been exposed to 3D printing at school, and it's going to become part of the norm. To learn more about it, and there's just so many areas where you can go to see 3D printers.
Well, website for you guys, social media feeds or anything like that?
Yeah, we artcenter.edu. If you go on our website. I was asked a question, what kind of events are coming up? We're in this pandemic has really, curtailed. Students aren't on campus at the moment. One of the good things that I can talk about there is that the fact that it's kind of a seamless transition for students to use bureau services and the 3D labs, even when they're working from home or wherever, or if they're staying abroad. They can send files to the labs. We can process those files, make the parts, and ship them back to the students. Right. So that's really, if you think about this pandemic, 3D printing has just been, it's been interrupted, but it's not been interrupted on the scale that you would have, for example, with a traditional shop. So, I think it's probably got a shot in the arm from just literally the fact that you can send a file anywhere, we can ship a part anywhere. We don't have to physically be there. So 3D printing is going strong. Our service bureau here at the school is in business every day.
Well, we kind of kicked off our Mimaki Live series with a little bit of that at the early stages of the pandemic with some of the applications we were doing for the pandemic. So we talked quite a bit about that, and we have resident experts.
Yes, we have resident experts coming up. We also do have some of the COVID signage and 3D objects you can make pertaining to COVID. We have some of those examples and files on our website if you go to our COVID page. Thank you, David, for joining us. We're going to have you on the Q&A along with Josh Hope, Jaime Martinez, Fred Kaplan, all of our 3D team. They're going to be joining us in a second after this quick commercial break. Lisa Humrich, our moderator, is going to be looking at the chat. She's been going through, finding your questions. Keep on posting them. We'll get to all of them as soon as we can. We'll be right back.
Mimaki's latest machine can 3D print very big models up to 1.8 meters high at an exceptional high speed. Let me introduce the 3D GD 1800. The 3D GD 1800 can print objects up to 1.8 meters in just 7 hours. The machine is so big, you can stand on the build table and perform maintenance to this machine. A big plus of the machine is the software. We have special tools inside our software that check the model, so you know before you start to print if you will succeed. In general, we can say that this machine can print overhangs up to 50 degrees without the need of any support material. It's even possible to close the top layer of your 3D object without the need of any support material or infill. The machine can print in 3 different quality modes. We have the normal mode, the quality mode and the high resolution. Which mode suits your project the best depends on speed, parameter width and used nozzle size. If you are owning a 3D GD1800, you mostly print 3D objects hollow. If you want to make them stronger, you can easily fill the hollow objects with expanding polyurethane foam. Another possibility with the 3D GD1800 is that you can make molds and fill them with concrete. In our software, you can select inside or outside support, which makes it quite easy for mold makers. Simply because the support material doesn't sit on the inside, but sits on the outside, so it won't interfere with your mold. Let's zoom in on the gel. We are using a gel as a building material, and compared to other technologies like FDM printing, where you are using heat to melt the plastic, we are using UV light to cure and solidify the material. This will give you a much higher print speed than you can expect with FDM technology. Aside from the speed, the gel is also translucent, so you can light your 3D objects from the inside to the outside. Another benefit of the MG100 gel is that you can connect multiple printed objects together as a glue. Plus, you can use it to touch up minor mistakes on your 3D printed object. When we look at the printheads, 2 things stand out. The 3D GD1800 is equipped with 2 printheads that can print at different heights on the same time. So you can print 2 objects in one go. The nozzle diameter of the printhead is 1.8 or 2.6 millimeters. The printheads are also equipped with an automatic cleaning system for the nozzle tip. The last fun fact of this machine, we made a special program for really long print jobs. So you can pause the print overnight and start it back up the next morning. That wraps up 15 things you didn't know about Mimaki's 3D GD1800. Thank you for watching.
All right, and we're back. Okay, we have our panel on with us. Everyone's here. Thanks everyone for joining us, including Lisa Humrich, our wonderful moderator. Lisa, are you with us?
I am.
Hi. Do we have any questions we can answer about 3D? I know me and Mike will be kind of stepping back a little bit. We have the actual experts here, so any questions for them are very welcome.
All right, well, let's hit it. We have several actually, and we have a couple of participants that are really excited about 3D. So
Nice.
Let's start with the first question. Josh, I think maybe this is a question for you. Baki asks, are you using G-code as a software language?
So G-code is definitely used throughout 3D, and definitely in the small, our 3D FF222 FDM printer. That is very much using G-code. The other 2 printers are still using G-code, but it's in a little more complex way. You're not able on either of those 2 machines to send straight G-code just to the 3D UJ553 or the 3D GD1800. They require a little more finessing through software. But yeah, the smaller machine, the 3D FF222 is definitely pretty much straight.
Perfect. His follow-on question was also related to the 3D UJ553. He was curious about whether it can print small parts for electronic circuits.
It can definitely print small parts. It could print small parts that look exactly like electronic circuits, but it does not have the ability currently to do, it does not have the ability currently to do any kind of conductive things or anything along those lines.
Right. The next question is related to garages, fleet garages. And the question is, can 3D printing help with a mechanics garage?
Definitely. Unfortunately, I don't think any of our machines necessarily could, although I think the same technology that we use in our 3D GD 1800, which is a gel technology. So if you're familiar with FDM, where it comes from a filament, this is a similar type printer, just in a much, much larger scale, and you're starting with a gel that's UV cured to a solid. That technology has actually been used in the automotive world for prototyping body parts for cars. But as far as in a true mechanics garage, you would be looking probably at some of the other technologies that are using more carbon-based materials or certainly metal-based materials. Even to some of the higher-end production cars, like some of the high-end BMWs, they actually use 3D printed metal parts in their production machines as well for their production cars.
Sure.
Yeah, David, are any of your students doing that currently?
Yeah, I mean, in terms of, like Josh said, transportation and cars, are using these technologies, especially the metal technologies. It's allowing them to lighten the weight. It really is trickle down from racing, from formula cars, where things like brake calipers have been refined and redesigned, where they can only be manufactured using 3D printing with this laser powder technology called SLS. So yeah, again, those machines are quite high end, but there's plenty of service bureaus that are out there that are using that technology and selling that technology.
I would imagine there's some proofing going on as well for like future products or like test fitting to see if something will work.
Prototyping, yeah, that's the industry basically grew out of the prototyping world.
Yeah, we've got a sample of a prototype seat here in the studio with us.
Right. So Radical Curing is now asking, what is the smallest UV curable inkjet 3D printer available? And he says, I'm not talking for a consumer market, but a high volume of professional locations.
That might be a better question for David. Our machine,
Right.
I'm not sure when you say smallest, if you're talking layer thickness, or you're talking actual part, or what that would be.
I think what's happening out there, and I'm seeing a lot of it. I was just looking at something just yesterday where they're talking micro and nano type resin technology. It's a very specialized area. If it's a really small part you're trying to make, I'm not sure, like Josh said, is it just a lot of little parts or is it really small parts?
Yeah, and his question doesn't really indicate, the exact size of the item that he's questioning.
Our machine typically runs at down to 22 micron layer thickness for the Z height. We do have a special mode when we're doing clear and color parts together that's down to 19 microns. I think that's pretty comparable to most machines and then the photopolymer resin market right now. But certainly there are some other specialized technology that could be a lot smaller than that.
So typically for fluid dynamics, they'll be using the liquid SLA printers. That's the question.
Okay.
Yeah, but they can always reach out to us and we can see if it's something that we can meet their needs.
Sure.
He just, or she, I'm not sure if it's a he or a she, because it's Radical Curing is the name of our follower here. And they just posted again in the chat and it says, I'm talking about footprint of the printer.
Oh, the size.
Yeah, in regards to the smallest 3D printer that's available with UV curable inkjet capabilities.
So that's a really great question. Our machine right now, the 3D UJ553 is 20 inches by 20 inches by 12 inches, which is a large industrial machine. What I will tell you is that Mimaki is very committed to the 3D technologies, and I recommend that you stay tuned soon, and you can maybe answer that question a little bit better.
Stay tuned for more, right, Josh?
Exactly.
Well, there's another question about open source. When it comes to materials and to our printers, can the user substitute custom-made UV curable inkjet formulations?
Not at this time, no, not for our machine. The Mimaki, the 3D UJ553, it does use a chip system for each of the inks. So this helps us to track not only what's the batch, what the expiration date is, things like that, and it helps to keep the machine, ensure that it's running the highest quality resins that it was designed to run, so it stays within our warranty window. So at this point, it's strictly Mimaki materials.
And if
And
I
if-
can add to that,
Oh, go ahead.
on the part side, Josh, and I think you can probably kind of expand upon this a little bit, but it is a print head, and print heads can be costly if you don't run the proper fluids through them. It's not like a traditional little desktop 3D printer where you can just replace the nozzle very easily, and it's a relatively inexpensive part. The print heads are very high industrial and relatively expensive parts if you do damage them.
Right.
So moving on to file formats, Jaime, can you share with us what file formats our 3D printers support?
Yes, so we basically have the STL file format that can be used, and that's the one that is widely known for the 3D printing community, especially the hobbyists, and also most of the CAD users. That's the basic one. We also have the 3MF format, OBJ, VRML, and PLY. So 3MF, OBJ, VRML, and PLY actually do support color. So one thing is color, vertex color, which is some metadata that is added to the mesh structure. And so that will represent the color on the screen. And also there is texture mapping. So it's basically to turn that mesh into a 2D representation and actually create a wrap into it. So it will the color will wrap on that mesh. So those are basically so the 3D UJ553 is the one that where you can use most of the formats, and all the other printers can use either STL or OBJ.
And Jaime, Fred, or Josh, as far as the coloring part is concerned, are there specific inks that are used for coloring?
So the way that the 3D UJ553 works, the best analogy I think of is it's a lot like an M&M candy. If you were to take any of these prints, like this print that's behind me here, and you were to cut it in half, you would see that the center of the print is a mix of white and clear inks, and the color inks are just being used on the outside edge. The machine prints with a photopolymer resin, and those resins are pigmented. So the clear, which has no pigment in it whatsoever, and then we have clear with a white pigment with a cyan, magenta, yellow, and black. So while we're coloring it, it's different than other technologies where they are using one material and then jetting traditional inkjet ink onto that material. We're actually printing and forming with that same resin, just with the pigments inside of it. So there's no structural difference between the color layer and the internal layer.
Well, that makes sense. We do have a question from the audience about whether the Mimaki inkjet printers are currently being used in the dental market.
I'm gonna let Fred take that.
Okay. It's definitely an interesting question. I mean, it's something that is being looked at for sure. It's kind of something that we could necessarily talk about. But what I'd suggest is the person asking that question to contact us, and we could have a more specific conversation about it. There might be, I mean, maybe an NDA may need to be signed to look at this, but there's, in terms of color, specifically, there are applications that lend itself towards dental.
That's a great segue, because we do have a question about who's the best person to reach out to about 3D at Mimaki.
I'll
I would say
volunteer.
at this point it would be Fred.
Contact me. So FKAPLAN@mimaki.com.
Everyone you see on the screen right now is an expert and would love to field any questions you guys have.
Absolutely.
So as far as milestones go for 3D printers, Baki, an audience member, was very excited about it. And he's currently studying art history. And he's curious, David, whether you're accepting students for 3D art research.
3D art research, yeah, again, thinking about all the different disciplines that are out there, and it's touched on a technology that is, very on the leading edge of preservation of art and museums. This technology lends itself to replicate, in particular, Mimaki color printers can replicate things that, museum quality pieces that you can't do any other way. In terms of classes that directly link to that, I don't know, maybe environmental design or something like that would be akin to that.
That reminds me of a project, Josh, that Mimaki participated in this year at the Smithsonian. Maybe you might want to mention a little bit about that.
Yeah, so the Smithsonian actually has a 3D UJ553 that is in their exhibits program or their exhibits group. So they use that for creating exhibits that are in the Smithsonian museum system. The one that we saw recently was actually it was a little bit well, it was a virus scan that was done pre-pandemic, which was very interesting. That was shown, but yeah, they use it for the Smithsonian has a huge 3D program there, scanning their physical category or catalog of pieces and putting them online virtually. So that's really exciting to see, and then we're also really happy to be a part of that Smithsonian program, and we're excited to see what projects they come up with next.
Yeah, I bet they don't have anything quite like the prop you have behind you, Josh.
This little guy or this little guy?
The big guy back there.
This one, yeah. So that's from the well, as you saw in the video there, that's from the 3D GD 1800, which Jaime printed out. This was actually a file supplied to us from our friends at Mimaki Europe. So thank you so much to them for helping us out. And then so Jaime printed that out. Jaime, how many hours was it to print that piece?
So for the popsicle print, I have 5 hours and 28 minutes for the ice part. I have 2 hours and 30 minutes for the wooden stick, and the base, which is looks like it's melting. That part is 2 hours and 55 minutes.
So you've got about 10 hours of printing, and then we've got the printing that Lewis did for the color and for the stick, and then probably a couple hours on wrapping. But it's a really exciting technology for the POP market, for the display market, to be able to print these really large pieces and then apply color to them. They can be painted or they can be wrapped with vinyl, and it's a really great technology, and we love how it matches up to our 2D printing products, and we think that's just a fantastic match made in heaven.
Yeah, how tall is that, Josh? About 4 feet?
It's so tall. No, I don't know, quite 4 feet. I would all together, it's about 3 feet tall.
Okay, so 3 foot POP display like that can be produced in relatively like a workday. Really, if you want to stay a little bit over, but it's basically one workday. It's complete to finish and to delivery to your customers. That's amazing.
And if you like print out the pieces for wrapping at the same time, that's it's cuts down on your hours. Yeah.
Wow.
Yeah, and that machine has the ability to print almost 6 feet tall, so it's really impressive.
Kind of like me, almost 6 feet tall.
We can go on to the next question. Mimaki doesn't endorse. Mimaki doesn't endorse lies. Let's keep on. Let's keep on going.
Josh, what about UV protection?
UV protection for the prints themselves.
Well, for the 3D object, before it's being wrapped, like the popsicle that you have behind you.
So both the 3D GD 1800 and the 3D UJ 553, those are both UV cured processes. So they harden with UV light. So especially the 1800, once you've got that and you've wrapped it, the 3D object is completely encased. So UV would really be more about the material that you're wrapping it with, and inks and things like that. And our inks, especially the solvent inks and the UV inks, are very light fast, so they weather really, really well. On the color machine, it's again also UV cured, and we found that we don't see really any fading on these parts at all, probably 3 to 5 years. Unless they're sitting out in direct sunlight. I wouldn't recommend taking something like this and standing it in your front window. But in a traditional just open environment, really not an issue.
So Josh, on the pieces that are sanded and painted or wrapped, they're going to adopt the characteristics of the paint and or the wrap material, correct?
Correct.
Yeah, if you used that particular piece, the popsicle, that's glossy laminate that we use that gives it that shiny effect, and that was fully wrapped in that. I feel like if we did that again, we should probably like wrap the popsicle in like use the actual popsicle part with glossy laminate, and then the wood part matte laminate. You can switch around different textured laminate to get some cool effects for those kind of objects.
Very cool.
Yeah, or if you wanted to get fancy, you could use one of our UV printers to add texture to it.
Yeah, absolutely. That was printed on the CJV. I think we use SS21 for those. But yeah, you could definitely switch those up. The laminate would protect all of those if you're using like a US 200, as long as the user inks is flexible, can curve around those like extreme surfaces depending on what kind of object you're printing out. Yeah, you get some really cool effects.
Yeah. Ladies and gentlemen, we only have a couple more questions, so I highly encourage you to drop your questions in the chat window. Otherwise, here quickly, we're going to be ending the question and answer session. We do have just another one that just popped up. Any comments on the required post-cure process needed?
So that again would depend on the technology that we're talking about. For really any of the three that we have, there shouldn't be any post-curing that's required. They're UV cured in the machines. There isn't any post-curing that's required for any of them, for FDM, for the gel, or for the photopolymer resin. The only post-curing type thing that can be done is on the photopolymer resins for the clear inks, or for the clear resins. There are some formulations that benefit from a photo bleaching, being underneath a daylight balanced light for a few hours. But other than that, there's no additional external or post-printing curing that's required.
Yeah, that's a great question, because in the other part of our world with sign and graphics, after products are printed on vinyl, there's a time period that you have to allow the inks to outgas. With 3D printing, correct me if I'm wrong, but you can, as soon as you print something like the popsicle behind you, you could immediately apply paint or vinyl to it, correct?
Correct.
Yeah, and you can also do the same thing on our UV curable products as well. They're ready to go right out the machine.
Oh, that's a good point. Yeah.
Yeah.
Right. It just applies to solvent inks.
Yep.
All right. So last question I have, unless the audience throws us a curveball. David, actually, there's two questions. I'm sorry. David, do y'all offer any training or webinars, in addition to the traditional classes that you have?
Yeah, we have Art Center at Night, which is those classes tend to offer, the general public, all different kinds of people who are looking for different enrichment or just want to get to know a subject and not necessarily going to college to learn it. So yeah, there's a wide range of classes, Art Center at Night. that can accommodate. There's some that use 3D printing, traditional shops, crafts, and different things like that. So we have a lot of different labs that are, all the facilities of Art Center are available to these night classes on either campus, of the South Campus, which is in downtown Pasadena, or the Hillside Campus here near the Rose Bowl. So yeah, again, go on the website and look at the classes that are being offered, being either regular classes or night Art Center at night or Art Center X.
And Josh, how about Mimaki?
We've got a lot of things going on. We obviously have the tips and trips things that's happening on the YouTube. We've got a lot of things that we're showing on Instagram and things like that as far as new projects that we're working on. But I think the tips and tricks through the Mimaki YouTube page is probably the best place to get any in-depth training on any of our products to help figure out the best workflows and new ways to do things that you've been doing.
I understand that Jaime has recently worked on a partnership or a class with Adobe, I believe.
Yeah, so apparently I should have segued a little better there. Sorry about that. Jaime has done a couple of tutorials that are now on Adobe Magazine, or excuse me, Substance Magazine. That's the best place to check those out. So he's done some great tutorials on using Adobe Substance and how to prepare files for a 3D workflow. We've also actually on the Mimaki USA YouTube page, we've done a couple tutorials there as well with Jaime doing work with Substance. And those are great resources.
Josh is just being shy.
We have a lot of training coming up. I think we're going to be adding in some 3D elements into our tips and tricks videos, like Josh said. That'll be a good addition. All of that information will be posted once again online. The second any of that's done, I think the tips and tricks thing is live, but all of those videos are populated on our webpage afterwards. We actually have MFG Day coming up soon, and November 12th, I believe, at 10 to 12.
12, yeah.
Yeah, so that resource you can register through ISA right now.
Right.
So that's a good training implement that you can go through us.
Yeah, for those of you that don't know ISA, it's one of our previous guests, the International Sign Association. This is a co-hosted event supported by them. Very proud to be participating in it, and we are bringing 3D into it.
Right. Yeah.
So it's going to be interesting as we continue to expand. So great questions, Lisa. How are we doing? Do we get any more?
I actually have two more.
keep them coming. We're here for you. We're here for you.
Fred, I think this one's for you. If somebody doesn't have a Mimaki 3D printer, how can they have prints made?
Excellent. Yeah, so there's a couple service bureaus that we recommend. So either CAD Blue, who's nationwide, and or Objects Unlimited, who's in the Toronto area, but both of them do a great job making individual projects for you.
Perfect. Last question, guys. David, this one's for you. If you could give past David, new to the 3D industry David, any advice, what would that be?
Any advice to get into the 3D printing industry? Is that what
Absolutely.
You mean? Yeah, well, I think, what would be good advice to get into it? I think just, if you're a maker, if you like to make things, and that's what piqued my interest. If you're a maker and you think about traditional ways of making things, and then you see a 3D printer actually build, these incredible things layer by layer, it becomes like, okay, eureka, this is the future. To get into it, really, again, it's like I say, it's everywhere. It's, it's on the internet. Companies are out there. Visit companies, look at technologies. There's a lot of web pages that are literally just dedicated to 3D printing, and just study it. Yeah.
Now,
Good.
is that
Oh, go ahead.
kind of technology something that Art Center has, being able to talk to yourself in the past, and that covers space and time, or?
Space and time.
So we at Mimaki would love to get
That's
to
4D. We haven't got there yet.
Oh yeah, 4D. Sorry. Well,
Yeah.
that's coming later. Japan's working on that. We're good.
Yeah, we're going to go straight to 5D. Forget 4D. We're going to 5D. I mean, 4D exists. I mean, this is the art of creating something that's going to morph into something else.
Yeah.
3D printers are already printing 4D parts. So think about that. You're printing something using a material with a memory or whatever. It becomes a fourth dimension. So you can do that.
Beautiful.
Wow. Great
Ed,
stuff.
I understand you're an alumni for Art Center College of Design.
Yeah, no, I highly recommend it. And if I may, just kind of pigtail off of David's answer, is that I find that just there's a lot of research out there online. There's a website called fabaloo.com, which has got kind of daily information about the industry. So all those are great resources to get into the industry. And the thing that's happening is it's happening in real time. So anything, all of us have something to offer, whatever we bring to 3D printing. There's a way to take whatever your skill set is into and move the industry forward. So I don't know if that answered the question about me being an alumni, but I'm a very loyal alumni to Art Center.
No, that was a great answer. Ladies and gentlemen, that concludes our question and answer session.
Great. Thank you so much, 3D team, for participating in this Mimaki Live. We really appreciate you guys kind of taking the helm here. We've enjoyed taking a little bit of a back seat. This is our 5th episode here, and we've certainly enjoyed every one of the moments in each one of those episodes. But this was particularly fun for us because it's a subject that we don't get to talk about a lot in our particular area of expertise. So thank you, Josh. Thank you, Jaime, Fred. David, we can't thank you enough for bringing an outside perspective to the conversation. Thank you so much.
Okay, you're welcome. Thank you for having me.
Yeah, this has been great. I wanted to say thanks again, piggybacking on that. We sort of film these based off stuff the application team has done, based off some of like the contacts we have. This one was the first one that we have done that was almost entirely dependent on a separate team in the Mimaki family. So thank you guys. This wouldn't have been possible without you guys. Appreciate it.
Yeah, thank you, our audience, for participating. We really appreciate the questions, the answers. Great things. And if you haven't gotten an answer that you're looking for, or you think of something after the broadcast, or you're watching this now that it's posted up on YouTube and you're not watching it live, go to artcenter.edu, go to mimakiusa.com, interface with us, follow us on social, follow, subscribe, all the great things. And we will get you the information that you're looking for one way or another. We're here to help you out. So thank you so much. So to kind of wrap things up, we're going to cut the broadcast here. And we have a special announcement coming up in about 2 weeks. So we're going to leave you with just a quick little teaser of that announcement. And we're going to thank you for your time today.
Thanks. Yeah, we'll see you. Yeah, we'll see you next time, everybody.
Okay. Bye.